All right, looks like we're live. So today I want to write a Go version of Ngrok. Why? Just because why not? So what is Ngrok? Ngrok is a small service that is establishing like a tunnel from your local machine to the public internet, resulting in the ability to expose to anywhere from the outside a service that you have on your local machine without having to worry about port forwarding, like a NAT traversal or anything like this. And it also offers like HTTPS for free, so that is also pretty cool. So our goal today is going to be able to have like a server and a client, and when the client says start a tunnel to that port, is going to publicly expose it to the internet. So let's get started from scratch. Go mode init Ngrok. That is going to be our starting point. We're going to have a client and we're going to have a server as well. We are going to start with the server, main.go for instance. We are going to have a main. What is going to be our main? Is going to be a test. We call it run. Let's make sure that we actually compile. We do. That is pretty nice. Once that is done, we're going to create a small HTTP service. So let's make a controller, for instance, to hold our state and our method. So we can create like a small method that's going to be handle create tunnel, for instance. That is going to be http.response writer and http.request. So that way we have a proper http.handle func. And that we will give that to actually we don't really need a context here. That is a boilerplate. We don't really need anything, I will just run. We can also get rid of our success, we don't need that. Let's see, we're going to do http.handle handle func on slash, so why not c.handle create tunnel, and of course we need to have a C. Our C is going to be our controller, and we are going to populate it in just a bit. Let's call it maybe not slash, but slash new, maybe. All right, and then of course we're going to do like http.listen server, and we're going to listen server on 1990 because why not? And if that fails, we can return an error. Error have http.listen and serve, and also like probably something like error.is http.server closed. Yep, so if it's an expected server close, we don't really need to fail. So that is good. Let's do a small test of printf w hello. Once we have this, we can run it, and we can do a curl localhost on 1990. Not found /new hello. All right, that is pretty encouraging. Now that we have this, we want to create a tunnel. So in order to do that, we are going to hijack the underlying HTTP connection, and that is usually quite easy to do, especially with in Go. We can do http.hijacker, and we can say that hijacker OK. If that is not the case, like that is actually a developer error, so we're going to directly panic. We're going to say that W is not hijacker. That should never happen. But then we have our hijacker, so we can hijack it. What does the hijack return? A connection, a read-write buffer, and an error. We are going to worry about the connection. We don't really care about the buffer and the error. And if that fails, it may be some HTTP issue or something wrong under the hood. Let's see, hijack, and there is no error here, so we're just going to log it. Printf error hijacking and return, because as we hijack, like, we don't really expect the client to be able to get like the response right now. But let's first see if that works. If that does work, no, we're not going to send hello to the response writer. We're going to send hello to the hijacked connection. So let's do that, and let's see if that works. That looks pretty good. But then we will need more custom client. So let's create a client. We have our clients directory, that's good. Let's go to clients, main.go. We can create a tiny main. Let's call it run. And that is going to actually connect to that to our server. And in order to connect, it's going to be a simple net.dial on TCP. And in our case, it's going to be localhost 1990. Let's see, what do we have? It returns a connection and an error. If that fails, we do want to know that it failed. Dialed, oops, sorry there. If it does not fail, we want to clean up. Con.close. The best effort, because we don't really care too much if that fails to close. And the first thing we will do is, well, basically consume the connection. So like we can do io.copy of whether tested out and for connection. And let's see if that actually works. Go run client, client. It doesn't do much. Why doesn't it do much? Probably because it should actually tap into the HTTP layer first, which I forgot, of course, fprintf for connection, and because that is on the /new, we will want to do something like HTTP 1.1. No, that is going to be a response. It has been a while. It's going to be get/new HTTP /1.1. That is how it works, and it's separated by \n. We can give it also some header, like forgot if that's necessary or not, but let's do that anyway. And that should be a better shape. Let's see. Hey, we have our hello. That is pretty good. So once we are here, we can. What will be the next step? The next step is to be able to say, like, now each time we call the server, it needs to go through the tunnel and from the client go to the destination. So let's see how we can do that. Let's start a Docker run. Let me think. I think I had something hello world, something like this, yes. That is a simple hello world that is going to be running, and here we can say, well, 8089, for instance. That is going to be the service locally that we want to expose to the world. If we go back to our localhost and we go to 8089, all right. So here we have a hello world HTTP, and the goal later on is to be able to get the same thing, but not from localhost, from the internet, and to be able to reach our local machine. Great. So the client here is going to point to that to where we want to go, but it's going to be everything through the tunnel. So now we do have the tunnel. That is pretty good. But what we want to do is actually like forward this. So we're going to create like another connection. Net.dial TCP. And this time it's not going to be on 1990, it's going to be our target. It's going to be 8089. If R, and in that phase, of course, we say that something is wrong. Net that dial to, and same thing here. Like we always want to clean up, but we don't really care about it. And in our case, so we're going to start from the connection to connection 2, and io.copy, excuse me, in the other side, which means that everything coming from that server connection is going to be forwarded directly to our local instance, and that should actually be pretty much for everything for our clients. Let's go back to our server, and in our server, what do? We have that hijack, and like now it means that everything coming from the outside we want to send to that connection. So it means that we will want to create something new from the outside. That should not be too difficult, but just for the sake of it, we are going to make that a little bit cleaner. So we'll say we're going to call it tunnels, which is a map of a string, and that is going to be net.con. Is that an interface or a class? It is an interface, all right. And once we're here, we're going to create probably like a random name similar to what Ngrok is doing, like it's already assigning a random ID. We're going to compute a uid.new. That should be good enough for now. Let's not tidy. Maybe not the most efficient not the most efficient way to have a random thing, but it is fine for now. We have our tunnel. What is our tunnel? It is indeed that map. No, I don't want to make it. I don't like make. All right. So now that we have this, what do we do? We're going to store our connection into our tunnel. So we have our c.tunnels of uuid.new. Is that returning a string or if uid or dot string? It's fine, and of course, because we are looking. It is a demo, but let's make sure that we don't have a recognition anyway. So we can do like c.emu.lock and c.emu.unlock, and that is equal to our connection. All right. Now that this is done, it means that we can basically like forward everything there. Let's see, how are we going to do that? How are we going to do that? We are going to, not really sure actually. Maybe we can create a new HTTP service so we can reuse the same one. Let's create a new one. Let's create a new HTTP service that is going to be slightly different, so that way we have one for the yes, okay. So yeah, just to avoid confusion and to avoid overlap, we're going to create a second HTTP service that is going to be sent on a different port, and that is going to serve basically what we have from the outside to our tunnel. It is still going to be through the controller, but in this case, like we can just log.print http.listen and serve 21. That is going to be in a Go function, just because that is blocking and we want to have the two of them running. And of course, this time is going to be into its own mux. So like instead of using the default mux, we're going to create the mux, let's call it API mux, http.newServMux, and we're going to register the function on that thing instead and call it API mux here. So that way it is isolated. And once we are here, we will do forward mux, same thing, new serve mux, and our forward mux dot handle func from pretty much everything to forward, or like handle forward. All right, and now we just need to have that handle forward method. Controller handle forward. It is also going to be HTTP handler func. So we have a response writer and a request. And that is going to do the actual forwarding. So we have the actual ID here, and we will with the connection. So what we are going to do, something that I should have mentioned, is that I already set up my DNS. We have star.grok.crick.net that points to that points here. So what we're going to do, we're going to look at what is in that prefix, and we're going to use that in order to know where to forward. So let's try real quick. We are just going to do like a printf for now, just printing it. The rec.host, because I believe that is pretty much everything we need. And it is on 1991, so that is good already. And let's try. So we have, for instance, this thing, and there is an issue of protocol. What is going on here? Not really sure. Yes, it's because I put that in plain HTTP and not in HTTPS. That let's make it HTTPS right away. That will simplify things, because I forgot that is indeed what we want to do. TLS, I think that is it. And that is a cert file and a key file. And I got that in my certbot. That is the key that I want. So it's going to be /home/crick/ certbot/grok.crick.net /cert1.pem, for instance, and pretty much the same thing for the key. Oops. Priv key1.pem, and that should work this time. Nope. Let's see what is going on. Nope. Let's kill this. Let's kill this. Because this is definitely wrong. We start with the address, then the cert file, then the key file, then the handler. All right, I'm not sure why it didn't crash and failed, but that is the story for a different time. Let's see. All right, so now we do have our host, and the idea here is that we're going to look into our map, see if we have this in our host or not. So let's do that. Excuse me. We are going to string.splits host. We're going to split on the dots because the first part is the one we care about, and we're going to extract the first part. So that is good. That is going to be our ID. Tunnel ID. And what we do with that, we're going to do a c.mutex lock. We could do like a read-write mutex, but like maybe a bit overkill. And we can say that our column equal at c.tunnels of tunnel ID. That is great. And now we can say that if con is nil, and or maybe we could be pedantic and say something like this, if okay or that, then, and what do we do if that is the case? Well, we return, and we can say simply like http.error w tunnel or like target not found, http.statue not found. We do have station found, okay, awesome. And if that is if that is found though, we are going to forward the request through that tunnel. And how do we do that? That's actually a good question. I believe we do have http util new client con that is going to basically like use a raw connection into this. If we use nil, I do believe it is deprecated, but well, we can just use it for now. And we say do of the request itself, and that if there's a response, if error is not nil, then like we will say http.error fmt.error f. What do we say here? Actually, to do forward, something like this. Not really original, but well, it will do the trick. And the code in this case is going to be a statue. I believe it's going to be 502, 503, bad getaway. We can say bad getaway. And if that is not the case, then we basically are going to forward back the response. So what do we have in the response? We have the statue code. That is going to be the most important. This is where we and we also have all the headers. So we have response.header. KV range header. We can say, and of course, resp2, because we already. Actually, no, we don't have another response. That is great. We do have w.header.set set of k, and we don't really want that v here because v is going to be a list. Resp.header.get of k. That is going to set our header. Then we can say write response, write header with our code. And finally, we can say io.copy of w and ref.body. And then, like, if something goes wrong, I mean, just for the sake of it, dot close as a best effort. And actually, even this, like, we don't really care too much if that fails. Like, if it fails, it most likely like a client disconnect or something like this, and this just says that it is deprecated, but well, we will use it for now. We can improve it later. I don't believe there is an alternative of that deprecated method right now. All right, let's try. What do we have? What we are missing is of course going to be like the actual ID. So right now we're just going to log it just to test it, and it's going to be ID. All right. Now we can use our clients. It means that we have this ID. That is great. And if we do our curl of HTTPS of that ID .grok.creek.net forward persistent connection closed. That is not what we expected. Do forward permission closed. Why would that be the case? Okay, so that is actually like quite expected in the client. If we go back to the client, do forward. Oh, no, that was not in the. Where did we put the do forward? It's in the server. Do forward. Okay, it is right here. Okay, so no, I didn't expect that at all. At all. It says that the connection is closed. That is frustrating. That is frustrating indeed. Why would it say that? Let me think. So at least it means that the tunnel was created. It's actually there. Let's do something a bit more simple for now. Say fmt printf for connection. Hello. And that, of course, is not going to be an actual HTTP response, so we can actually do that. HTTP/1.1. I believe it's something like this. I am not very confident on this thing, but well, let's try. Go run. Maybe the only one. Oh, maybe not, but at least we get, actually we don't, we get HTTP2. What is going on here? Yes, that makes that makes a lot of sense because I'm actually writing to the destination and not to the parent. So that is indeed quite expected. So in order to solve this, that is not what we're going to do at all. To simplify things, ordinarily we are going to make it hard-coded to something, like the exact one that we had right here. So that way I don't need to copy-paste it again and again and again, at least while we develop. We can just make it like this. All right, and then what I want to do is to do going to kill this. Actually, we see that we did receive what we expected. So, but for now, in std-lkp, I believe it was on 8089. We rerun our clients, so we have the ID that we expect, and this time we should see something on our netcat. And we don't, because of course I removed it. And why did I remove it? Let's see. We are here. Oop. Where are we? We are right there. All right. So well, this is it is nonsense, but at least it should send something. Oops. All right. So we see that we have hell. Why do we have hell in our netcat? And this is why we do this test, to try to understand. At which point did I do that? I mean, yes, right there. That makes a lot of sense. Okay. So it does prove that the connection is working. So maybe there's something wrong with that client con thingy. That would say that the underlying connection is at. What if we were to do like a new request? New request. Let's call it the method get on slash and http dot nobody or slash foo. Let's see what that would do. We also see that we have an issue because once we restart the server, the Go client should terminate as well, and it does not. So that is a bit concerning, but let's see. All right, so now we are hanging because we never return, and we do send all this, which is good. Which is good. Now we can let's try again with an actual HTTP server and see if that will do the same thing. Or if we will get the error. We do get the error. To forward, persistent connection closed. And that is actually a bit strange. Let's see if we can isolate that error and just discard it, because it's actually quite expected in this case. I mean, we can always improve later. Let's see, aborted, missing. We did get slash foo. So the forward worked. It's just an issue with that single piece. Well, let's get rid of that deprecated method. We should have done that from the beginning, and let's do it slightly better. So to do it better, we're going to create a client, which is going to be http.client. And that client is going to have a transport. And that transport is going to be http.transport. And that is going to have a dial, or even a dial context, which is even better. But let's just do it. Let's just do a dial for now. We can improve later if needed. It is just a prototype and a demo. In our dial, we want to return Archon. And then we can do client.do of request. And resp error, if error is not nil, we can do that. How does that look? Can't be set in client request. What? Get slash. HTTP request at request URI can't be set in client request. I see. So we do need to create a new request. Let's do that. Request 2 http.new request with context. Our context is going to be our request1.context. Our method 2 method is going to be .method rec.url .string. Our body is going to be the rec.body. And of course, we're going to have range rec.header. That is going to be rec2.header.set of rec1.header.get of k. And set k. And I believe that should maybe do the trick. Let's see. Oops. Imported protocol scheme. Okay, why not? Let's see, what do we have in that URL? Oops. Okay, the URL is just slash, so that is why it does not like it. So in order to make that work, we will need to keep it, and we can basically fake it. We can just say HTTP localhost, because anyway we override the dial method, so where it's going to go doesn't really matter, but we can keep this. Hello all, and just for the sake of it, in that bottom pane, I am on my local machine, completely on the outside, and on that upper one, I am on the server, and the server itself, basically just using that loopback, but it would work one way or the other. And now we can see that by just going through the internet, we can forward to something locally. Although now we have 502. Because the connection was closed and kept closed. Okay, that makes sense. Let's see if we can fix that. And first I'd like to reproduce. The first time works. The second time fails. Interesting. Interesting. It means that the connection was closed. Is it done at the client level or is it done at the server level though? Let's go back to the client just to see what we have here. And we can put some function. Con to. let's see what that is going to do. So on the client side, it is on the client side that it is done. All right. That is not really what I was hoping for. And we have, so it is con2 that closes first. Well, that is actually quite a simple fix. Loop. Actually, the loop is going to be running from one side. Actually, no, we do need to have this. That's actually a bit tricky, because if we do the loop, well, we can try. Let's just try that. Go to loop. So we have the same problem. Interesting. It looks like the actual the connection itself may be done as well. Yes. It means that the remote is also closed. So that is a bit frustrating. Why would that be the case? Let's try something real quick, just to see if it is the forwarder that is going to fail us. Let's create an open up closer con struct, which is going to be a net.con. Oops, net.con with open up closer con close. Attempt to close. And here we're going to send that here and say like a nop closer con of con of that. Let's see. And indeed, we have the close. Well, if we actually prevent that, let's see. It worked once. It didn't work the second time. Why would that be the case? The con2 was closed. And the con2 which makes sense, but this one never closes. So we need a way to tell it to not do that. Ah, la, 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 la. Well, we can pretty much do the same thing on the other side, because we know we don't want the HTTP library to close. So we will do exactly the same thing here. Except that on this side it is not HTTP, so it does not really work that way. Well, we need to put in place pipes and whatnot. Let me think. All right. One simple solution, I mean, not really like the best, maybe not the best, but that would do the trick, is to look at the implementation of our copy and do something similar. Our size, basically 32K by per 32K. All right, should be easy enough. Should be easy enough. We're going to do that here. We're going to call it con2net.con. I'm going to do go func, and here we're going to do a buff. So we're going to use the same size, 32K, and I'm going to make another loop as well. Go to loop buff. Nope, we'll say like con.read of buff. And an error. If we have an error, we're going to just go print it. Read. And then we are going to send con2.write. Right, and what do we write? We write, well, buff of n. All right, we also need a mutex, thing.mutex. Con2, require con2, mu.lock, mu.unlock. All right. Con2, column equal at this, mu.lock, mu.unlock, con2 equal at con2. And that should do the trick. Let's see. Oops. It works once, and it works many times. It worked twice. Why did it work only twice this time? It worked once. It worked twice. Alright, so basically, if it is too fast, it does not like it. Oh well. Oops. Good enough for today. It's a proof it's a proof concept. The next step is to clean up a bit everything, to make that forward client a bit more robust. Maybe using the HTTP util new single host reverse proxy. That probably will be much more like robust, but at least we have a way to forward from the outside locally to a service. And that's all for today.